What do we get for question number 1? What did you get for that one, Leanna?
I did the same one first.
Oh, you did? Okay. Who got an answer for number 1?
0.422.
0.422, good. So then the second one is 4, choose 2, times our probability 3/10 raised to the n, or sorry, the x power, times our probability of a fail, which is 1 minus 0.3 or 0.7, raised to the n minus x. What did you get for that one, Leanna?
0.265.
Anybody else? Yes, good. Probability then that x equals 3 is going to be 5, and choose x. Probability of success raised to the n power, or the x power, sorry. Probability of a fail, 1 minus p, raised to the n minus x. And then what did you get for that one? 0.3456. Or, since I said 3 decimal places, 346. That's just a cool number. It just came out that way. Okay, good. So there's a little bit of practice using the binomial probability formula. It's a mouthful. And then a couple examples. So example 1, a statistician working for the UC Bearcats has the task of figuring out what the probability is that the team wins a game. Each win earns the team a bonus from the athletic department of $1,000 for use on team swag. The statistician calculated that this probability is 3 in 5 for any given game. So what are the chances that in 15 games the team wins every game? Let's see. So we have step 1. Step 1 said identify the success. So success, winning. Step 2 says identify the probability for success. So the probability is 3 out of 5. So that's going to be a 0.6. Step 3 says identify the number of Bernoulli trials. How many Bernoulli trials are there? 15? So I'm literally referring back to these steps right here. So step 4 is the time then when we use that formula. I'm going to rewrite it on this page just so we can keep in mind what we're doing. So n choose x, p to the x times 1 minus p to the n minus x. Like I said, writing out these steps helps because then all we're doing at this point is plugging things in. So the probability that x equals, how many successes do we want? 15. We want all wins. So n choose x, 15 choose 15, times the probability of winning, raised to the x, times the probability of losing, 1 minus p, raised to the n minus x. 15 minus 15 is 0. Anybody know what 15 choose 15 will be? 1. Yep. What's anything to the 0 power? 1. So essentially, like, these kind of cancel themselves out. They're just 1 times. So we really just need to do 0.6 to the 15th power in our calculators. What'd you get for that one, Kyle?
0.6 to the 15th power?
Yep.
It says 4.701, and is the e to the negative fourth thing?
4.7.
E to the negative fourth.
Okay, I'll just go. E to the negative 4th. Does anybody remember what that means?
4 zeros, right?
Scientific notation.
It is scientific notation. Yeah, so it's times 10 to the negative fourth is how you would write that out. And then that negative fourth power means to shift this decimal point 4 spots to the left, which means we would need 3 zeros as placeholders. So pretty much there's a chance. Any Bearcats fans in here? Just me?
I'm kind of obligated to be since we got first.
Yes, that's a good idea. They did not win against the Xavier Musketeers on Saturday at the Crosstown Shootout. It's a really sad day, but it's okay. We'll move on. The season is not yet over. However, it's not going to be a 15 for 15. We're not going to have 15-0. All right, question 5. Last one of the day. Your chances of finding water on planet Mars are 1 out of 20 visits. The climate is really improving there. I wrote this. What are the chances you'll find water 2 times or fewer in 20 visits to Mars? Step 1. What is a success?
Finding water.
Yes. All right, step 2. What's the probability of a success? 1 out of 20. Or 5/100ths, 0.05. Number of trials? 20. And we're writing the formula, binomial probability formula. Probability that x, now here's the tricky part, 2 times or fewer. So less than or equal to 20. Probability that x is less than or equal to 20. No, to 2. Probability that x is less than or equal to 2. So that's going to equal, we're going to have to add a few of these together. Add together the probability that x equals 0, probability that x equals 1, and the probability that x equals 2. Thankfully, we have this formula, so we don't have to do all 20 probabilities. We just have to find 3. So we'll start with the probability that x equals 0. So we've got n choose x times the probability of success times the number of successes times the probability of a fail times the number of fails. What's 20 choose 0? What are we going to get for that? So 0 successes. Just 1. Remember, and we saw that here. Fail, fail, fail. How many ways were there to fail every time? Just 1 way. So that's going to be a 1. We know anything to the 0 power is 1. So really all we have to do is the 0.95 to the 20th power, which is what? Madeline?
0.258.
Thank you. And then the probability that x equals 1. So 20 choose 1. Again, don't make fraction lines. Super tempting to make a fraction line. 0.05 to the first power times 0.95 to the 20 minus 1, 19th power. 20 choose 1. What's that going to be? 20, right? 0.05 to the first power. What's that going to be? 0.05. So simplify your life by just doing some calculations in your head. .377. Is that what you got? And lastly, the probability that x equals 2. So 20 choose 2. Choose 2 successes. Probability of getting a success to the power of x. Probability of a fail times n minus x, the number of failures. At this point, you may want to go ahead and use your combination key. .429. Is that what you got? Am I wrong? No? Does anybody else get .429? Second, instead of the 18th. Thanks. How about .189? Okay. Whew. So then, to find the probability that x is less than or equal to 2, we add those all up. Point. All right, so there you go. The chances of finding water 2 or fewer times is pretty high, so what then would be the probability of finding water more than 2 times? Yes. The complement. So 1 minus . So sometimes it's easier to add up 3 binomial probabilities and then subtract from 1 than to find 17. So what did you get then when you subtracted from 1? Read. 1 minus .924. Good. It's kind of nice. We're at a point where with binomial probabilities, we can kind of see the inner workings, but then we can boil it down to a formula. And then using these 4 steps, it should make the process pretty simple to do.